get these community members access to learning resources, access to interesting Java jobs, and also access to sessions by speakers like the one we have today. And with our webinars, the goal is to get our community members familiarize themselves with new frameworks, and also learn new things that are on the cutting edge of tech, and see how they could use them in their day-to-day work to become more productive. Today's webinar will focus on Kotlin, one of the coolest programming languages we have today. Kotlin works with all operating systems, including iOS, macOS, and also embedded systems. It is easy to understand, and being a successor to Java, the uptake's pretty good, and it's also gaining a lot of popularity among first-time mobile app developers because of its expressive style and its interoperability and performance. Kotlin is also recommended by Google for building Android apps, and you have a very good community of developers supporting each other online. And you see a lot of traction with respect to large companies trying to use Kotlin for production mobile applications. But today's session will focus on using Kotlin for server-side app development. So we will see what frameworks and libraries we have and how it makes the whole development process fun. And to take us through this really interesting topic, we have Anton Arhipov, joins us from Estonia. He's been a long and active contributor in the Java, Spring, and Kotlin space. He has over 15 years of work experience in software development, and in his long and eventful career, he has done several things, worn several hats. So he started off as a developer and then became product manager, and later a developer advocate. So he knows what it means to be a developer, doing these things, and he's currently at JetBrains, and he's a developer advocate for Kotlin. So I mean, you can't get a better speaker to talk about this topic, and really privileged to have you with us today, Anton. So over to you.
Thank you very much for the introduction. So hello everybody, and yes, we're going to talk about Kotlin for server-side application development. It's a great topic. It's my favorite one. And so I will slightly reintroduce myself because, well, it was a great introduction, but I think I will add some facts just a little bit. I'm located in Estonia, Tallinn, and I work remotely for JetBrains, and I work with a few interesting products that they built. Of course, everybody knows IntelliJ IDEA, that is the greatest IDE for Java development, but also for Kotlin development. And there are other products that I work with, like TeamCity, the continuous integration server, and the Kadana, that's the code quality platform based on the engines that we have in IntelliJ IDEA for static code analysis. So when you type something in the IDE shows you the warnings or shows you some errors or hints. The same engines that are doing this can be used within the code quality platform to check your code for style, for hidden errors, for anything like that. And yeah, like for the past 3 years, I've been closely working with Kotlin team, and my goal is to educate people on how to use Kotlin. And I also gathered the feedback about the tooling, about the programming language, about various use cases. I talked to different companies, how they use Kotlin, and bring it back to the team so that the team can figure out what else they can do to make the life of developers easier. You can follow me on Twitter. I'm pretty active there, but yeah, so you can find me by the name. It's pretty easy. I also contribute to Kotlin YouTube channel. So if you are looking for any content on how to do something with Kotlin, you can type youtube.com/Kotlin, and you will find a few of the videos that me and my colleagues are producing for you. So let's talk about Kotlin, and that's our main topic today. Actually, if you go to the website, you will see a few square boxes right on the top of the web page. Those are the boxes where we highlight the different verticals, different technology areas where Kotlin could be applied, especially Android development, multi-platform mobile development, web front-end development, and of course server side. That's the main topic today. But also we are experimenting in the other areas where Kotlin could be used. For instance, data science is getting more and more popular, and we internally build different libraries and tools for data science as well. So if you go and check that, you will find some interesting webinars also on our YouTube channel where you can learn about various, uh, interesting topics in that domain as well. So a little bit of history. Kotlin was actually created as an alternative JVM language in 2011, more than 10 years ago. At that time, Java as a language was not developing very fast. We were waiting for Java 7 to appear with Lambda expressions, and well, we didn't get them in Java 7. We got them 3 years after in 2014 with Java 8. But nevertheless, since the evolution of Java language was pretty slow at that time, a lot of different JVM languages appeared, like alternative JVM languages, and Kotlin was one of them. And well, it turned out to be hitting the spot in terms of the features, the value adds that people expected from Java, and were forced to wait for them. And somehow, like, people liked it, and well, it became a success that we see today. And meanwhile, while we were waiting for lambdas to appear in Java, actually Kotlin started to experiment with different programming language platforms for Android, for like transpiling Kotlin to JavaScript, native platforms. Now even we have web apps assembly backend that's currently kind of experimental in development, but we hope to get something interesting out of that work as well. And in 2017, it turned out that Google liked it so much, the alternative JVM language so much, that they announced it as a officially supported language on Android platform. And since 2019, it became a kind of the primary language for Android developers. And today, more than 80% of the apps in the Play Store are actually implemented in Kotlin. And today, if we look what Kotlin has become, it became a multi-platform programming language. Of course, JVM is the primary focus for Kotlin today, but you can develop for different platforms with it. And the interesting fact about it is that Kotlin does not try to replace the whole ecosystem on some technology platform. Instead, it tries to integrate with what already exists. So Kotlin has a very great interoperability with Java on JVM platform. And if we go into iOS development, then Kotlin tries to integrate with Swift and Objective-C. And if we go to the native platform, there is integration for C programming language. And if we develop something for the web, there is like the integration with JavaScript as well. So there is no replacement. There is rather integration with the underlying platform. I've been told, as I said, I've been talking to a lot of developers and a lot of companies why they adopt Kotlin, and it's great to see that the features we incorporated into the language, into the platform, are hitting the spot that they highlight some of the features. I tried to group them together, and well, concise and modern. What they say about the language is that well, they like the syntax, right? compared to Java, like if you have been programming in Java for a long time, Java has a baggage of the features that they cannot break. Of course, Kotlin has it now too, because it's been 10 years of development. We have to be very careful with adding new features and that we shouldn't break. But we were able to start later and learn from the smarter people in the community in the different languages. So Kotlin incorporated a lot of this knowledge into its design, and it feels really modern today, and it's really concise. So there are some reports that you will implement the program in Kotlin in slightly lower number of lines than in Java. I think it's not the um, primary criteria for the program, that it should be shorter, it should be correct and performant. But it's a nice thing to have less lines of code, because you can read less, you can maintain less code, the probability of making an error also diminishes with less code. The great value add of Kotlin was that from the beginning, we thought of improving the type system, and the greatest improvement is the aim to solve this $1 million mistake with nulls, with null pointer exceptions that we really hate in Java. Since then, actually, a lot of other languages incorporated this feature as well, so it turned out to be very useful. But today, if someone asks me, like, what is the single most important feature of Kotlin, I would say that's null safety. Of course, they say that multi-platform feature of Kotlin is really great, that you can reuse the same code for different platforms, basically write less code that is platform specific, and extract some common code into some reusable library, for instance. That's a great feature. And as a matter of fact, if we write this kind of code between the platforms, one of the hardest problems is actually concurrency. And for that, you need a good abstraction that would work in the same way on different platforms. And Kotlin provides this abstraction with coroutines. Coroutines is this feature that has a minimal support of the language, but actually implemented as a library, so that the compiler makes use of the underlying library and makes the corresponding compiler checks for async programming. That's really great. So it comes with the language. And well, we looked at the library that exists for Java developers today with JDK, and we thought that we can improve on top of that to provide a little bit better experience, to provide more value add. So people actually like the standard library of Kotlin very much. We do have a lot of videos and tutorials on different aspects and features in the standard library. So if you are interested in learning more idiomatic way of programming in Kotlin, besides syntax features that we are going to look into today as well, make sure you learn about the standard library, and it's really fun. It's really fun. So generally, the sentiment is that as long as you're not looking into Kotlin and you haven't programmed in it, you don't really care. And if you just start reading about it, you don't really see this benefit right away, because it feels like just slightly more modern Java. But if you actually program in it, if you try it for a demo project, for your home project, for your pet project, for whatever, you try it and you feel that it's really great. So that was the general sentiment by the developers who tried it, and they wanted to stay with it. So usually if people try Kotlin, they stay programming in Kotlin. One interesting thing about the use cases that we have learned about is how companies are adopting Kotlin specifically for server-side development with JVM. We do collect those stories on our website, so if you want to read about them, it's easy to find. You just go to the homepage, and from there to the server side, and you will see the use cases. Like, there is basically a big button that guides you there. But I would like to highlight some of the some of the stories here. First of all, of course, at JetBrains, we are using Kotlin extensively for developing different products, different internal applications. And one of the biggest products that we have in the application area for Kotlin is Space. We have launched it a couple of years ago, and it's a collaboration platform that uses Kotlin just everywhere. It uses it on all the interfaces on the mobile applications for different platforms like Android and iOS. Desktop application that is actually an Electron, but still there are some specifics to it. And of course, web browser, web application. On the backend, it runs our own homegrown framework that is actually an open source framework, and it's a pretty popular one. So Kotlin is everywhere, and thanks to the multi-platform abilities of the compiler infrastructure, we can reuse a lot of code between the interfaces, but also between the backend and the front end. For instance, we could have the same code for validation rules and models, so we can just, we don't have to duplicate the code between the front end and back end. The other interesting case that you can find there is about Jira. So everybody knows Jira. That used to be a huge monolithic application for issue tracking. And years back, Atlassian decided that they want to take it to the cloud. And this application could not scale just right away. And they decided to change the architecture. And while changing the architecture, they decided to update the technology stack as well. So their technology stack is based on Spring. So it's a classic Spring Boot application, but with Kotlin. And they do use reactive features. That at the time of the report, they said that they are using Project Reactor, but looking towards adopting coroutines. So maybe it already happened. We did not update the story yet. And the outcome was that they were breaking this big Java monolith into smaller services, and all the new smaller services were implemented in Kotlin. So basically, every new microservice is just a greenfield project where they re-implement the functionality in this new language. And but their sentiment was that it makes them productive. It's really cool to hear. Developer happiness is very important, and well, they are happy. But the different story is by Expedia Group. They also had a great huge monolith implemented in Java, but the way they adopted Kotlin was vice versa, very different to what Atlassian did. Instead of breaking the monolith into the microservices and writing the new services in the new language, they actually took Kotlin and integrated into the existing code base. So there is the same project, and they are starting to write Kotlin in the existing Java project. That is, there are different requirements. It's a different workflow, because the Java code that is in your project has to coexist with Kotlin as well. So their approach was to write new code in Kotlin, and as soon as you have to change something in Java code, they decided, okay, we will convert. If you have to change Java, you just convert to Kotlin. If you can do that within meaningful time frame, let's say in one day. If it's not possible, then it stays in Java, and so it's a mixed code base. But the benefits, you can see them on the slide right now. The features of the language, why they liked it, is that it actually is very capable, as they said, it's very capable of working with GraphQL. So GraphQL library for Kotlin is developed by Expedia, and it's a very nice one. And the other very extreme story actually is by Adobe that you can find from our website as well. The link is there. The thing is, Adobe probably by their creative products like Adobe Photoshop, Illustrator, some others. But in fact, Adobe runs a huge digital platform that serves a lot of requests, billions of events, and so on. And what they said is that adopting Kotlin with a non-blocking I/O by means of coroutines actually saved a lot of money on the infrastructure. So it gave them huge cost savings. It's not just a nicer syntax. It's not just a null safety that the language provides, but also coroutines that were giving them this benefit for huge cost savings. So just to summarize here, what cases we had the use case for extreme code reuse with Kotlin multi-platform. That's basically a JetBrains product. We have this Jira software that is being rewritten from and re-architected into microservices architecture with pretty standard technology stack on top of Spring. And there's a nice, interesting case of migration to Kotlin by Expedia. There's a huge platform by Adobe that adopts Kotlin, and it's already in production, and it's pretty successful. And a cherry on the top, Google. Yes, we have heard that Google adopted Kotlin for Android, but actually Google uses Kotlin for the server side as well. And just recently, they have been delivering the presentation on this, sharing their challenges adopting Kotlin within Google scale, because because of the specifics, like what tooling they have, what are the internal requirements, and so on for the programming languages. So they are not so standard as we see in the open source community, but they shared it, they are using it, and they are saying that a lot of benefits encountered when they actually started adopting Kotlin. All right, so if you want to read about those, we have more. We are trying to publish more use cases. Of course, the list is not exhaustive. So if you Google for more articles who uses Kotlin for server-side development, you probably will find something that is not listed here. So Kotlin is very good for enterprise development, for server-side development as alternative JVM language, but as Java developers, we would often ask, like, what kind of framework, tools, libraries we can use with this new language that promises something. And tooling, of course, like the great benefit of all those cases that I have just was talking about is that you can reuse a lot from your Java experience. So if you're using IntelliJ, you can still stay within IntelliJ and program in Kotlin. If you're using Gradle or Maven for building your project, that stays the same. A lot of tools that were available for years for Java developers have been either providing the extensions or support for Kotlin in the latest years. And the framework and libraries landscape looks pretty much the same. I would say Kotlin has a little more because we can use all the same libraries as Java developers, plus we have Kotlin libraries that are specifically written by Kotlin developers for Kotlin developers. So if you look at the list of the frameworks that we have today, Spring, Micronaut, Quarkus, Helidon, they either provide first-class support for Kotlin or provide an official extension for better user experience with Kotlin. Or if there are like smaller frameworks, they either might not provide an official extension, but there is a community extension for Kotlin that adopts the API for the specifics of the language. But even if there's no extension that is specific for Kotlin, you can still use the Java frameworks thanks to the interoperability. But besides that, since Kotlin is a great language for libraries as well, then the community started building frameworks with it, building libraries with it. And at JetBrains, we are building Ktor framework that is an open source project, and there is a small team behind it that maintains it and adds more features. So today I want to cover the most popular framework in the Java space, how people are using it with Kotlin, how you can too. And we're gonna look into Ktor as well. So most of the code I have today are in the slides, but if you check from my GitHub account, you will actually find some repositories with the sample code as well. So I'm not gonna do a lot of live coding today, just to save the time, because it's a lot, and most of the code will be on the slide. So let's talk about Spring with Kotlin first. Actually, you can find a lot of materials, a lot of tutorials, documentation, presentations, video tutorials about using Spring with Kotlin on our website and YouTube channel. You can find that as well. I have contributed some tutorials to the Spring guides with Kotlin as well. For instance, the Spring Boot with Kotlin and RSocket. That's a reactive tutorial, like where you can build a reactive application with Kotlin coroutines, RSocket, Project Reactor, and Webflux. We created that with Oleg Dakuka, who is actually the Project Reactor contributor. And if you look into the documentation for Spring Framework and Spring Boot as well, you will see that all the code samples are in Java and Kotlin. You can switch between the samples and see how to write a specific thing in a specific code snippet in Java and Kotlin as well. If you try to generate a project, like there are multiple ways to do that. Of course, you can use the wizard in the IDE, but there is also a very popular application, a web-based application where you can just select which technologies, libraries, dependencies you want to add to your Spring project. And as a matter of fact, one of the options is Kotlin as well. So if you generate the project from the beginning using that application, it will generate a Gradle project with Kotlin, and that Gradle configuration file will be based on Kotlin as well. And if we check that, we'll see that, okay, this specific example is actually a Groovy one, because when I was generating it, I didn't pay attention. But normally you would see build.gradle.kts here, and the syntax will be slightly different. But what I wanted to highlight here is that you will get some additional dependencies and plugins generated into your configuration. So in this example, you can see that there's like an import first. The Kotlin compile task is imported, and that could be used for more fine-grained configuration of the compiler for this project. Then we have a few lines of plugins declared in this build file, and two of them are related to Kotlin, like the Kotlin compiler specifically. And there are some things in Java frameworks, like they try to generate proxies. They assume with some of the defaults that we have with Java programming language that are not the same in Kotlin. For instance, we have classes that are declared, like classes in Kotlin are declared as closed by default, and Java it's open by default. So Spring just adds a few plugins, actually one plugin that automates the experience slightly within the project. So it adds open modifier automatically during the compilation, so that our code is not polluted with the keyword open everywhere. Then you also will see a couple of extra dependencies for reflection, because Kotlin has some language features that are different from Java language, and therefore reflection capabilities are slightly different, and therefore we need this dependency to introspect the classes that are implemented in Kotlin. But otherwise, it looks pretty much the same as if you were using it with Java. And at the end, we have a compiler task for the Kotlin, where we can provide some extra configurations like flags if we need to. I will explain those flags of this like free compiler args, what it means, this what means this option a little bit later. So if we look at the application, it looks pretty much the same as in Java. It's slightly different syntax because in Kotlin, the class declaration is a bit shorter. You don't have to have a class body, for instance, if you are declaring the class, it's just one line. And then we have top level functions. So the main function should not be declared within a scope of a class. We can just declare it on a top level. Therefore, it looks slightly shorter, but pretty much the same. There is not much of a difference. However, as soon as we try to run the application, use the Spring run application function, and if we try look into the declaration of this function, we will see there is a lot of interesting things and that are not familiar to a Java developer. And if you have not learned Kotlin yet, then they're quite different. So you can see like something like inlined, reified. You can see a little bit different syntax for the declaration. You can see some star operator. So that is all different. And this is something we want to explore and learn. Okay, so if we go further and we declare a REST controller with a couple of functions, you can see it also does not differ very much. There are slight differences in syntax. For instance, the constructor, the primary constructor for the class is declared on the same line with the class declaration, as opposed to when we have it in Java inside the class itself. And like functions and methods could be declared using this interesting syntax with a equals mark instead of having like a block of code with curly braces like here. So I will explain what it is in a minute. Further on, it's pretty much the same, and I wanted to actually go into the IDE for better browsing. So it's the same project. Let's explore it a little bit. So we have everything in one file just for convenience. As a matter of fact, because you write less code, and in many cases the declarations fit like a couple of lines, it's changing the way we actually write code, because I noticed that I don't want to create a separate class, separate file for a class. I often just put a few classes into the same file, and instead of declaring it as a with the class name, I'm declaring it by the package name. So it kind of changes the way we structure the application a little bit, because we write less code. But for this specific demo, there is not so much code, and we can just put everything in one file. And this application basically uses one table in the database. It connects there, selects some data, and sends it as a response to some endpoint, some HTTP endpoint. So this run application, if we browse there inside the library, it's provided by the Spring framework. So as I said, Spring has first-class support for Kotlin, but it's a Java framework. So they actually ship Kotlin extensions within the jars that they provide, and there are two functions as an entry point for the application. One is just with a parameter list of strings, and the other one is the same, but also adds an initializer that is actually a lambda expression, a block of code, so that when we invoke run application in our code, let's see, we can either call it with the list of parameters, or we can also supply a block of code where we have access to the Spring application class, so that if I type this, I get access to all the attributes of Spring application class here. So I can provide extra configurations programmatically. So for this specific case, when my application starts, I add a few initializers in this block, actually just one, where I'm using the bin definition DSL also provided by Spring Framework. If I go here, I will see this open class bin definition DSL is part of Spring Framework again. So I can use this DSLs provided by the framework itself to configure it somehow. In this specific case, I'm registering one bin that is a command line runner, and it runs when the application is initialized, when it starts up, and it just makes a few requests, not a few requests, but one request into the database. It finds the messages from the repository and prints whatever I have in the database into the command line. So let me check the database. I have this custom H2 database here, and we have a public schema with one table that is messages, and we have a couple of columns, and we map a data class to that table with two fields. So it maps to messages table. And if we try to select it, select something from that table using the SQL query, we get everything, right? So we can actually check that. We can, right from the editor, we can actually run the query in console and connect to the database immediately and see if we have anything there. Yes, I already have a few messages, a few entries in my messages table. Now I can just disconnect from the database because H2 is not a concurrent database right now for me. It's file based, so I have to disconnect before I actually run the application. And when I run the application, remember there was an initializer that prints all the messages on the startup, right? So it's just a little code that does some initialization, provides some information about the data that I have in my application. Now the application actually runs, and if I try to request something from the database, let's say I want to run this HTTP query like this. Let me run it from a GET request. I get all the same messages in the JSON format, and of course I have a post endpoint as well. If I type something here as a message and I send the message to the application, to the post endpoint, I get the response that the ID was generated, the UUID. And now if I check how many messages do I have, I can compare to the previous results as well. For instance, right here. No? Okay, probably I deleted too much. But anyways, we now have the message that we posted into the database. It returns back with the whole list. So that's a very small application. You can actually find how to implement it yourself within the on our website. In the documentation, we have a full tutorial, step by step explaining some language features. But I want to highlight one thing here that I already mentioned. This syntax here, when you have one statement in a function, and you can use, instead of using like the like the classic syntax like this, you can actually use the expression body syntax um, like this, right? So if you just have one statement, you can convert it to this kind of declaration. But what it also means is that this equals mark, like the assignment operation, will also trigger type inference. So if you don't specify a type, the return type of this function will be the same as for the expression on the right hand side. And this has some implications. So if you're developing some API that is consumed by some other developers, then by changing the expression type, you will actually change the return type of this function. And that might be not a good thing if you're working with a public API of your library. And therefore, it can be configured so you can actually enforce the compiler to check such situations. And if your function is not private, then the compiler will actually show a warning or even a compiler error if and force you to actually specify the modifier that it should be either private or public. By default, it's public, and also the return type. So that could be done within the configuration file, like configuration block for Kotlin compiler in the Gradle configuration or Maven configuration as well, where I will say that I want it to be explicit. So I want my public API and all API should be explicit. Like if it's a public API, then there should not be type inference. And if it's a private API, it can be using type inference and so on. I will not spend time reloading the project. I'm just showing you that it's possible to configure. So I think it's important. What else could I show you here in this application? I think the rest is pretty much a standard if you have been using Spring Framework before. So we are going to proceed further. So that's the application. Data classes is like one important thing here, is that we are using data classes here in the small application, and they are fine to be used if you are using JDBC or any simple database access layer. But if you are using JPA, there are some requirements that JPA has, and the way it works and the way Kotlin works with data classes. So data classes are not the greatest fit for JPA. And if you are using JPA, then you should actually be using just normal classes for your entities. Otherwise, you will break lazy loading with data classes, and you will catch some of the behavior that you don't want to have in your application. So if you're using JDBC, data classes are fine. If you're using JPA, use normal classes. So if you are using JPA, then there are some extra configuration that needs to be done in the build file. You need to add another plugin that is called Open, that is doing also pretty much the same as Spring plugin, but specifically for JPA entities. And there is some configuration that you need to do. So otherwise it will not be behaving the way you expect it to work with Java. Let's skip that. So like just a small summary. It's important that the difference is in Kotlin classes are final by default, and you should be accounting for that. But compiler plugins are helping with this situation, so you will be fine if you just generate the project. The configuration will be generated for you automatically by the project wizard. But if you're adding Kotlin to an existing Java project, you should account for that and add that configuration manually. Data classes would not work with JPA really well. If you have very simple mappings, they will work. If you have like many-to-one connections, lazy loading, and so on, you better just proceed with normal classes instead of data classes. Yeah, and a good place to generate the configs is actually start.spring.io. You just go there, you select the properties, select the dependencies, whatever technologies you need, versions, and it generates the file for you. You can just copy the specific configuration block from the web application instead of trying to do that manually in your IDE. Let's talk a little bit more about the extensions that Spring provides. There is a whole block in the documentation about Kotlin in Spring Framework, but the important piece here is like the extensions for this specific part of my presentation. So there's a list of packages where they added those extensions, and you can live without them, but they make your life easier with Kotlin. It's just more convenient when you're programming in Kotlin because of those some specific features of the language. And if we check what extensions are, if you are not familiar, you can actually create extensions to the existing types that could be even some types that are provided by the library, or even standard classes in JDK. So for instance here, just to demonstrate that, for instance, we have a string, and there is no function that is called UUID in string, right? But we can declare that in a specific scope within the file, within the package, within some block even, we can narrow, make the scope as narrow as we want to. We can declare that there is an extension that looks like a function that returns a string, and it creates a UUID from the contents of the string. So could be a byte array. We can, if it's a single expression function, we can use that shorthand syntax, and we can see the applications of that in Spring Framework as well. So for instance here, JDBC template is like the very standard API in Spring Framework. It has been there since version 1, and as you can see, the query function is exactly the one that we have in Spring Framework for Java if we just execute the query. But if we want to run the same function with parameters and have the callback as a role mapper, then there is an interesting thing happening. So the first parameter is the SQL query itself. The second one is the role mapper. And then we have a list of parameters for that query. If it's 1, then it's 1 parameter that is required. If basically what I want to say, it's a var arg type of a parameter that we have in this function. And this function is also provided by the core function, core API of Spring Framework. But the role mapper is a functional interface. And in Kotlin, we can map functional interfaces to lambdas immediately, and the compiler will recognize that it's a specific type that the function call expects to have. So we call that feature SAM conversion. So the SAM conversion is performed by the compiler. You don't need to do anything. It's automatic and it's compiler checked. But then if it's a lambda, in Kotlin, it's very convenient to have a lambda at the very last position of the arguments list. But the ID is actually a var arg, so we could have multiple IDs in there. And in Java, it's not possible to declare a function with a variable number of parameters where the var arg is on the is not on the last position. Here it would be on the second position in the arguments list, and that's not possible. But in Kotlin, it is possible. And in Kotlin, we very often try to put lambda at the very last position because it's possible to move lambda out of the parentheses when we supply it as a parameter. And it looks shorter, more concise. It looks like a callback. It actually looks like a block of code next to the function call. And this is the way we program in Kotlin. And this this feature is called trailing lambda, right? So if you're looking for the name of this feature in the documentation, then it's a trailing lambda. And because of that, because of this language feature, to make it more convenient to use this API for Kotlin developers, Spring Team actually provided the extension for JDBC template that is located in JDBC operations extensions file within the same jar. So it's a new function. It's implemented in Kotlin, and Kotlin developers can use that. Good. So we talked about extensions and trailing lambdas. I have a few slides on that, but I will skip those because I already told you about those. And well, if you look at the slides later, you can just recall what I was talking about. Let me skip this one. There are more extensions, more conveniences for Kotlin developers in Spring Framework. For instance, if we are working with a model class that actually behaves like a map, but it does not implement map interface and does not derive from map interface. Therefore, we need to convert it into a map if we are working with it, if we want to put another value into it in Kotlin. And this square braces syntax is actually an extension function that is an operator overload in Kotlin. So you can overload some of the operators in Kotlin. By convention, you cannot create new operators, but you can overload some of the operators that are standard ones. But by the name, so the set operator is actually exactly what we see on the slide. But Spring developers decided that writing this as map function every time is tedious, and it would be nice to have a shorthand syntax for it. So they provided an extension, an overloaded operator that allows you to work with the model as it's a map, while it's not a map. So that's a very nice thing. And the DSLs, that is like a very specific feature in Kotlin. It's not really a language feature. It's a combination of different syntactical features in Kotlin that we can just use and combine. And in the documentation, we have it under the name of type-safe builders, but the community often prefers to use the word domain specific language. And I will show you in a second what it looks like. So in our application, we have this run application function that takes an extra parameter as a code block where I can run my initializers and create extra beans. So we can actually have a different context, some different implicit variables within that block. As you can see, the ID hints me that within that block, I have a reference to this, and that this variable is of type Spring application. We can control that by declaring a different signature of the function and saying that maybe whatever is happening within that block should be happening within some other class or within the context of some other type. What it provides us is that we can start creating like structures that looks very much like JSON. Like in this example, you can see that we open a block beans, and then there is a bean, then there is a command line runner, and this all looks like a document, right? So we declare that there are objects, and we build a structure with that. That is why we called it type-safe builders, because actually compiler will check what kind of types are located within the scope of those blocks that we use to declare this configuration. And those types are hinted to you when you're programming in the ID. So basically what we end up with is this kind of structures where we use trailing lambdas as parameters. In many cases, we would use a function declaration where we just have one parameter that is a functional type, a lambda, and then we can omit the braces around that lambda when we are calling this function, and therefore it looks like JSON. And one specific language feature that enables all of that is a lambda with the receiver. So like when I'm passing some lambda, some block of code as a parameter, I can also say that this specific functional type is actually an extension to some other type. And therefore, I will declare that whatever is happening within the block that I supply as a parameter is actually happening within a context of a specific type. In this case, it's a class, right? I have it declared like this. Okay. So I was talking about null safety as well. Null safety was like a very interesting feature, and I said that it's the single most important feature in my opinion, but it might be different for the others. You can read on this in our documentation, of course, but let me explain you very briefly. In Kotlin, you can declare types by default as non-nullable, but if you really want to, you can actually say that, okay, that specific variable may contain a null value by adding a question mark to the declaration, right? So you annotate the specific type, the specific declaration that, okay, I know that it might contain a null value, and therefore I will give a hint to the compiler to check if I'm using this variable safely or not. And in this situation, that would be a compilation error right now. So if person can be null, then dereferencing it by calling person.firstName would actually produce a null pointer exception. And compiler will check that, and instead of calling it like this, we need to call it safely, either with the safe call operator, question mark dot, or we have to explicitly check for a null, and the compiler will understand that we did check it. We did check for a null, and then it will be safe to actually call this parameter or any other function on that specific reference. So, and if I know what I'm doing, like it's actually an anti-pattern. We have an extra operator that looks ugly on purpose, the double exclamation mark. So it was made on purpose to make it ugly. So if you see it in your code, you can spot it immediately, and you will know that it's not the best code you could write. It might produce a null pointer exception, and maybe the author was too lazy to actually check for a null properly or model the domain properly. So it will be kind of a warning hint for you when you are looking at the code. But null safety in regards to Spring is slightly different here, because Spring is implemented in Java, and Java is a platform, and we work with Java classes as with platform types. And we cannot just force you to check for nulls every time you call a Java method or a function, or you work with a Java class. Then in Java platform, for null safety, there are a list of annotations that are specified by JSR 305, and Spring actually provides those annotations with the dependencies, and it's annotated everywhere, all the Java methods and functions. So for instance, how does it work? So if we annotate, let's say we have on the right, we have a class that with one function, and there is a parameter that we declared as a non-nullable, that it shouldn't be null when we call this function. And on the left, we are calling Java function from Kotlin code, like we declared a demo instance. If I could, no, I can't. So we have a demo variable. We got some string from somewhere, and we should use this string as a parameter to the foo function, and it might be null because we declared it as a nullable. then it will be actually detected by the compiler, and the compiler will tell you that it's not possible to supply this parameter. You have to check for null. You either will use this ugly operator, or will explicitly check for a null. This is the way you should be doing it actually. Or you can also use some like standard library functions like let. Those are coming from the standard library with the safe call operator together to execute this code. So the compiler will understand that you have explicitly checked for a null in this place, and it will be fine to execute this function with this parameter. In Spring, in the standard APIs, they have annotated the parameters as well. So if you try to call a query with a SQL query that is actually null as a string, then it will be a compilation error as well, and that's enabled by the compiler option in the build configuration that I already mentioned. So by now you have seen a lot of different features. This is not exhaustive list of features in the Kotlin programming language, but this list relates to the Spring framework right now. So they provide extensions, and extensions, Kotlin extensions, are enabled with with operator overloading, extension functions, type inference, to overcome some of the overhead that it might provide. There are inline functions in Kotlin, and of course we've been talking about data classes and some other things here. So GSR 305 specifically, that's part of Java ecosystem, and Kotlin compiler actually supports that out of the box. So let's talk about Ktor a little bit as well. That's another framework in JVM in Kotlin ecosystem specifically, because Spring is the most popular framework in Java ecosystem, and it's also the most popular framework among Kotlin developers. But Ktor is the other and very different framework. It's not really fair to actually call it a framework. It's rather like a library. We'll see why. And it's developed by a small team of developers at JetBrains. It's an open source project, and it's multi-platform. It's an open source, and you can build server and client apps with it. And why it's important that it's multi-platform? Actually, the client side of it can be used for mobile development and for web development, for front-end development. So you can use this library to target JavaScript platform, or iOS, or Android. And of course you can use it as like normal HTTP client on the JVM. And the server side of it has been supporting JVM for a long time, and now since version 2.0, it's not coming soon, it's already released. You can build it for the native platform as well. So you can develop something in Ktor with Kotlin and compile it to a native binary. That's pretty cool. In IntelliJ, we have a project wizard the same way as for Spring, and we also provide a web interface where you can also generate the project pretty much the same way as you could do that with Spring. And what is generated, you can enable different features, like if you need some integration with some libraries like templating libraries, or serialization, or authentication. Any features you need in your application are implemented using either a plugin or a third-party dependency that we integrate with, and you can select the list of the preferred plugins when you generate a project. So if we create a very, very minimal application, it looks like this. We have a main function, and basically we start an embedded server inside that JVM application, and then we can say, okay, we want to run it based on a net engine. We also can run it on Tomcat, embedded Tomcat, or embedded Jetty, or even on the embedded engine that is implemented by the Ktor team, that is based on purely on coroutines that could be compiled into native binary as well. We supply the port that could be fixed. It could be random as well, and then we specify the routing within this kind of a DSL-ish block. So you look at, when you look at this, it looks like we declare another document like within the block of code that we supply to embedded server. It looks very similar to what we had in Spring with run application call, right? So within this block, we can actually configure our endpoints the way we want. And since it's a pure Kotlin code, we can actually extract it and structure it the way we want. There is no like requirement on how you should structure your routes. It's up to you. And then we just start the application. And when you look at this code in the IDE, you will actually notice that the IDE highlights some of the lines with the special icon. This icon means that this call, when we like next to the line, next to the icon, the call on the same line is actually a asynchronous call. So the execution will be suspended and will be provided with the different task for the specific place. But it means that we are using coroutines. And if you look at the code that actively is using Ktor, like its APIs and so on, you will see a lot of those icons on the left, meaning that it's very asynchronous. It tries to use coroutines just everywhere. Let's skip the dependencies. But what can you do with Ktor? Like normally, or how can I do something with Ktor? It looks like it's very minimal. There is not much, not too many features in the framework when you try using it. The thing is, when you try it for the first time, okay, routing is easy. Like I can start the application, it responds to some HTTP request, cool. But what else can I do? Can I do persistence? There is no persistence out of the box with Ktor. How could I do logging? How could I do serialization? Anything else? That's what makes it different from Spring, right? Spring is a fully featured full stack framework. It provides you with all the integrations out of the box. Ktor is very minimal. It provides you features for writing HTTP apps. So it's kind of a library, not really a framework. And if you need to implement something like persistence logging, I know something else like templating, you will actually choose the libraries that you like best, you like most. So for instance, if you need to talk to database, you can choose any of the libraries you like. Maybe you have used Hibernate before, then you can actually integrate Hibernate. If you need something more lightweight, for instance, Juke is a great library for writing database apps. Then Juke works perfectly with Kotlin, and you can use that. And the same with the other parts of the infrastructure. Probably besides the authentication, that is something you want to actually the framework to provide. So authentication is supported in Ktor out of the box. And that's the difference between the two frameworks. So whether you use a full framework like Spring or a toolkit like Ktor, it's a matter of preference. I would say that some people prefer to have everything out of the box. Some people would like to tailor their set of libraries for their use case. I do have a demo. I will not be live coding it. I just want to show you how it feels and how it looks like when you have an application with Ktor in your IDE. Let me quickly switch the project right here. So I have one project that is actually a chat application based on WebSockets implemented with Ktor. And let's look at the application class. So as you can see, it starts from a main function, but it's slightly different from what we had in the slides. Instead of calling the embedded server, we're actually calling a specific engine directly. So there are four engines available out of the box with Ktor, and we are using Netty. In most cases, it's either default or we can change that, of course. And when we are using this engine to start the application, it actually gives us the possibility to configure our application using external configuration files. So when it starts, it will check the configuration file, and by default, it's very simple. It doesn't have this storage part. It's a custom one because I can actually implement my own structure for configuring the application. But the standard one contains this Ktor block, and where we specify two stanzas. The first one declares which ports I'm running on. Like I can specify the default port, but I can override it as well from the environment variable. And then in the application block, I can specify a list of modules of the application. And a module is actually a function. A function, we can navigate to that one. And it's a function, it can be any function, but we usually implement it as an extension function to the application class. An application class is a class from Ktor, so it's a library class, and it gives us access to the configuration and the environment. So if we need to read something from the environment, we can read within the scope of this extension function freely without, like, it's just convenient. So when we implement something in Ktor and we want to use some feature, some plugin, it's not enough to just add it into the class path. Like in Spring, we usually just add it into the class path and it's enabled already. In Ktor, you have to be explicit when you want to use some feature, like, and you have to call install function. So if we want to use WebSockets, we have a dependency first, and then in the module where we actually want to use this, we call install function with the singleton from the library and by the name, so WebSockets, and we supply a configuration block for the specific features that are provided by this plugin, of course. So, and next we can just declare routing block where we can, describe our handling logic, like the way we would respond to the application events or user requests specifically to that are specific to the endpoint. And in this case, I'm creating a WebSocket endpoint on the chat, and then I'm just tracking the connections like within the list, and I can send messages and send and receive the messages from the channel, the incoming channel that belongs to the WebSocket server factory, and that's it. So it feels very lightweight. It does not enforce you with any conventions. Actually, it's just the main function, the engine, and then you describe the logic for the specific endpoint, and that's it. And if I wanted, I could build it as a native image, as a Java library, and so it's up to you. What I wanted to highlight here is again the specific icons on the left. So you can see that some of the calls are asynchronous, and that's kind of a nature of Ktor, so it's built around coroutines. Initially, it was a test bed for coroutines, and it grew into a fully fledged toolkit for HTTP apps. And now people actually like it a lot. So now it was the end of my demo. I hope you had a great fun learning something new. I hope you learned at least one thing that will be useful to you. If you need to learn more, our YouTube channel is probably the greatest source of information on different topics related to Kotlin. Specifically right now, today, every day during December, we're actually hosting live sessions about solving the advent of code puzzlers. If you know what it is, it's like you get a task in the morning, and you have to solve it using any programming language. So our team members are actually hosting a live sessions in the evenings. Just in a couple of hours it will start. Every day, by solving different puzzlers, you can learn something new about the language and the standard library. If you're interested in some server-side programming topics specifically, there is a playlist for server-side Kotlin, and those are the webinars that I'm hosting time to time, like a few times of the year. And there you will find interesting sessions with our engineers, with external engineers who develop the frameworks, develop the libraries. They talk about different use cases, how those are applied, and how Kotlin actually helps them in their work. So if you have any questions to me today, I'm happy to answer, and I hope you enjoyed the session.
Thanks a lot, Anton, for a brilliant session. Really enjoyed the walkthroughs and demos on Kotlin and also Ktor. Ktor was really interesting. And also, I have a couple of questions, but yeah, I mean, I would encourage people to reach out to you on Twitter. But one question for the benefit of people on the call is on the webinar is this general questions came from a couple of people. So, how beginner friendly Kotlin is, for somebody who just knows Java and Spring Boot.
Oh, if you already know Java and Spring Boot, it's very beginner friendly. So on a Spring website, you will definitely find the tutorial, and actually it feels very lightweight in the beginning because let's say you will not immediately need all the advanced features of Kotlin when you start programming with it using Spring. You will just use the syntactic sugar that is very easy to learn. You don't really spend much time on learning it. You will just see that, oh, it immediately makes sense, right? So if you have time, let's say if you have time, let me open the browser. Let me open the browser so that I could show it to you. kotlinlang.org. So let's go to the docs. And there is basics part, right, in the menu. And I really suggest looking at this one page, and it really shows you like the basic things that you need to learn or get familiar with. I think I need to find time to update this page a little bit to add more examples, but it's slightly different. For instance, if you haven't learned Kotlin before, there are some highlights that you will see that are different from Java. For instance, there's the shorthand syntax for function declaration, or how the for loops are, written instead of the iteration. You would use this in operator. That totally makes sense. It reads really like easily, right? And a few other things that are now slightly different from Java is that you would use val instead of final var, and the type on the right. So you have to get used to that at first. then you will notice that you don't need to type semicolons at the end of the line every time. At the beginning, it doesn't feel like a big deal, but when you get used to this and you go back to Java, you will constantly realize that it's so annoying to type semicolons at the end of the line. And the other very interesting part, I don't know if we have it on the basic syntax page. Let me see, when expression. So a lot of the statements that otherwise are statements in Java, but are expressions in Kotlin. So if is an expression in Kotlin, it can return a value. In Java, it's a statement. We cannot return a value directly from if statement. Let me explain what I mean. So if I had, let me switch the file. So if I have if expression, let's say true, whatever, and I have a block of code here, I can just type string and the other string, or let's do it like this, 1 and 0, right? Sorry, I forgot else, right? It's an expression, and the last statement in the expression is actually a return value, so we don't have to put return in here, right? Otherwise, it would be a global return, but we need a local return for the if expression, and it means that we actually can extract this into a variable, and that's pretty much like a ternary operator in Java, and in Kotlin we don't have that, so we can just use the if expression. And the same goes about try catch block. So in Java it's a statement, it's a catch block, but in Kotlin we can assign a value out of that. So if we let's say do something like this, catch exception, so a will be 100. So that changes the way you write code. When you get used to that, you will realize that using this kind of small features of the language, that you can use expressions that return values, that you can use type inference, you can use expression body syntax, and some other features of the language of this, syntax sugar, will make your programs shorter, and you will immediately realize the benefits. So, and learning that is very simple. I mean, the IDE even helps you with that. In some cases, it will be highlighting that, hey, you can do it shorter. And so there are all kind of help that we can provide with the documentation and the IDE tooling as well. So like the general answer is like, it's very beginner friendly, especially if you are already using Java with Spring and Maven or Gradle.
Right, got that. So thanks a lot once again, Anton. Thanks a lot for a great session. And we will try and get you back for another one, hopefully next year.
Thank you for calling me.
Yeah, thanks a lot. Have a good evening ahead. Bye-bye.
Bye-bye.